Okay, so let's continue number 21. This was our recurrence relation, right, from the last video. And so now we want to find, again, our power series solution. So remember that we assumed that our power series, our solution to differential equations was a power series. So we have, we know it's C naught plus C1x plus C2x squared plus C3x3. And, well, what do we know? I mean, we can definitely find a pattern here by, letting n be 0 and 1 and so forth. But remember, we have our, this is initial value problem, right? We're given initial conditions. So let's go ahead and write those down. It's y of 0 equals 0, and y prime of 0 equals 1. And, I mean, here, without, I mean, if you substitute 0, right, y of 0, well, that's just c naught plus, okay, c1 times 0 plus c2 0 squared plus c3 0, cubed, dot, dot, dot. Hopefully, I mean, you can see that all these guys are going to be gone because there's 0. So I'm left with c naught is 0. So that's our first guy. Our second guy is pretty easy, right? We just take the, this is again a good review of using your initial value, your initial conditions. Y prime of 0, well, y prime of x is, let's see, we have c1 plus 2c2x plus 3c3x squared plus dot dot dot, and y prime of 0, and similarly, right, I mean, all these guys are going to be gone. I mean, any term that has an x, which, I mean, they all are going to have an x in, and because it's a power series of x, so we have this guy is 1 equals, this is gone. So here are our c naught and c1. So let's maybe, okay, so c naught is 1, c1 is 1. So now we want to find c2 using, again, our recurrence relation. So I'm going to let n be 0 in my recurrence relation. And if I let n be 0, right, I'm letting it be 0 because I want c2. And again, I'm just going to input my 0 for n, just like we've been doing. Okay, so if n is 0, using our recurrence relation, we have c, let's see, 0 plus 2, so c2, 2 times 0 plus 1, that's 1, cn plus 1 is, that's just c1, minus c naught all over n plus 2, so that's 2, actually 2 plus 0, yeah, 0 plus 2 is 2, 0 plus 1, okay, is 1. And let's see, this is, right, 2c1, but c1 is 1, so it's just 2 times 1, minus c naught, which is, actually my c naught was 0, it was not 1, that should be a 0. So that's just 0 all over 2, and I get 1. Okay, so let me write that down. Well, okay, so C2 is also 1. Okay, so what if n is 1? And I'm doing the same thing again, C3, and then I get 2 times 2C2 minus C1 all over 3 times 2. And let's see, I get C2 again, we know is 1, so that's just 4, right, 4 times 1, 4 minus 1 over, and this is just 6, so I get 3/6, which is a half, but I'm going to rewrite 1/2, and, well, actually, no, I'm going to leave it like that. This is actually fine. Let me just go ahead and erase that. So maybe let's write C3 is a half. Okay, so C, let me just move this over. If n is 2, again, C4 is 2 times 3, C3 minus C2 all over 4 times 3. And let's see, 2 times 3, 6, C3 is a half, minus C2, which is 1, over 4 times 3, which is 12. So we get 3 minus 1, well, that's pretty easy. So I just get 2 12s. Let's see, yes, 3 minus 1, 2, okay, 2 twelfths, but, which is actually 1/6. But I'm going to rewrite it as 1 over 3 factorial because we know 3 factorial is 3 times 2, which is 6. So I'm going to go ahead and rewrite it like that. And then I'm just going to write this out here just so I won't forget it later. And let's do one more. C5 is 2 times 4C4 minus C3. Sorry about that noise. That's my coffee brewing. So yeah. Okay, so C 2 times 4 is 8. C4, well, we just found C4. It was 1 sixth, or 1 over 3 factorial. So let's just write 1 over 6. Minus, oh, let's see, 8 6, and we can just write that as 3 6. That's a half. 5 times 4. Oh, excuse me. Oh, it's been a long week. And okay, so after, this is just arithmetic. After simplifying all that, we should get 1 24th, but I'm going to rewrite 24 as 4 factorial because I know 4 factorial is equal to 24. So that is my C4. And again, if you don't see the pattern yet, that's fine. Just get some more data, right? Let n equals 4 and 5 and 6 and so forth. So I'm going to go ahead and rewrite my, my C naughts. So I remember what they are. So C naught was, or my C naught was 0. C1 is 1, C2 is 1. I'll just write my C3 is 1/2. Oh my goodness. C4 is 1 over 3 factorial. C5 is 1 over 4 factorial. I mean, you can figure out, C6 is going to be, let's see, 1 over probably 5 factorial. All right, this is probably 2 factorial because it's the same thing as 2. Okay, so now let's go ahead and substitute it back into our y of x. So we have, y of x equals c1 plus, or c naught plus c1x plus c2x squared plus c3x cubed plus c4x to the fourth plus dot dot dot. Okay, c naught is 0, so that's gone. C1 is 1, so that's going to be x plus C2 is wonderful because that's 1, so x squared plus, okay, so 1/2, 1 over 2 factorial, x cubed, so I just did that one, plus C4, 1 over 3 factorial, x to the fourth. Let's go ahead and write C5 since we found it. 1 over 4 factorial. Oh my goodness. C3x x cubed, x to the fourth. Okay, that should be x to the fifth plus dot dot dot. Okay, 1 2 3 4 5. 1 2 3 4. Okay, so now that we have this, we ask ourselves, can we rewrite this as one of our elementary functions? Does it look like one of our elementary functions? And if you look back on page 195, it does look very familiar to e to the x. Not exactly e to the x, but we can, change this a bit using algebra. I can definitely fact out an x, right? That's our GCF, our greatest common factor. And if I do that, I get the following. Let's see, x squared plus 1 over 3 factorial x cubed plus 1 over 4 factorial x to the fourth plus dot dot dot. And yay, here's our familiar function, right? Our elementary function. This guy is e to the x. So there is our solution to our differential equation, our particular solution. And that is it. So we're done.